Hello class, today is the week of May 11th, and this is lesson number 1. So we're starting something new today. We're going to be talking about prime factorization of monomials, and then we're going to move into, for lesson 2, we're going to talk about how to simplify radicals, not by using a calculator, but by giving an exact answer. So let's dive off into this lesson real quick. So there's a couple things that you need to remember about prime factorization. 1, what is a prime number? Well, a prime number is a whole number greater than 1 with only 2 factors, 1 in itself. Okay, so a lot of times we forget what that is. So we need to remember that 1 is not a prime number. Okay, it doesn't start with 1, actually starts with 2. And then we also need to know what a composite number is. And a composite number is a whole number greater than 1 that has more than 2 factors. Well, you'll notice in these definitions, both of them start off with a whole number greater than 1. So that is a kind of a given for both of those types of numbers. And then for a prime number, you only have 2 factors. And for a composite number, has more than 2 factors. So when you look at, for prime number, the very first prime number is 2. Well, what are the only 2 factors of 2? 2 and 1. Okay, well, if I were to give you a number 6 for a composite number, well, it's got factors of 1, 2, 3, and 6. So it's got more than 2 factors. So that's what we need to remember about prime and composite numbers. Okay, so with that in mind, what are the first 10 prime numbers? Well, here are the first 10. You've got 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And they just keep going. If you remember back in elementary school, you had the 100 grid, or grid that had the numbers from 1 to 100, and you had to shade in what was prime and what was composite, things like that. So those are some of the examples that we have to deal with. Okay, so what is prime factorization then? Well, prime factorization is writing a number as the product of, which means you're going to be multiplying, the product of prime numbers. And we can use a factor tree for this. So take, for example, if I were to ask you to prime factor 24. Okay, well, prime factoring 24, what you would do for that is you would break it down into what kinds of things would multiply together to give 24. Well, there are several things that you could use. You could use 2 and 12. You could use 3 and 8. You could use 4 and 6. And I'll give you a hint. When you're doing prime factorization, the closer they are together, the smaller your factor tree will be. Okay, and every one of these, depending whichever one you chose, your bottom row of your factor tree will still be the same. So now this one's already pre-done for you. So what I chose 12 and 2, the 2 that were furthest apart. So you break the 24 into 12 and 2, then you break the 12 into 6 and 2. And once the number's prime, it just slides on down, doesn't get broken down anymore. And you don't break it down into 2 times 1, because remember, 1 is not a prime number. And then you end up with a bottom row. Okay, now that bottom row is the list of prime numbers. So every one of those numbers should be a prime number. That when I multiply all those together, I'll get 24. Now, typically back in elementary school, you would then write that in exponential form. You would take your numbers and you would put them in order. So you take these numbers right here, these 3 2s, and you would write it as 2 to the 3rd power times 3. Okay? Now, in today's lesson, you're not going to do this part. Okay, all you're going to do is give me the list of prime factors in number order. So for today's lesson, you would write 2, and what we're going to use in our Google form for a time sign is the asterisk. Okay, times 2, times 2, oops, didn't mean to do that one. Times 2, times 3. And that's how you would write it, no spaces. That's how you're going to be typing it into the form. So let's see if we can try another one. What about 54? Well, 54, the first 2 numbers that come to mind to give me 54 would be 6 times 9. Now you could use others. 27 times 2 will also work. Okay, there's some other things that will work, but just do the first 2 that come to your mind. And then we look at the 6 and the 9, and we ask, are they prime? Well, the 6 is not prime, so it'll break down into 2 times 3. And this 9 will also break down into 3 times 3. So we end up with 2 times 3 times 3 times 3. So you would type in 2, asterisk 3, asterisk 3, asterisk 3 for your answer. Now, this does lead up into our second lesson, so that's the reason why we're doing that. So just take my word for it. This is what I want you to do. Okay, now, what if I gave you this one? Oh, goodness. Well, if you'll notice on that previous screen, we just had a 54. Oh, my goodness, just a regular number. But now we have a monomial. Do we do it the same way? Pretty much, yes. Okay, so we start off with just the number itself. Okay, so you break the 28 down. Now, 28 could be broken down into 14 and 2, or it could be 7 times 4, okay, which is the one I'm going to choose. Okay, the 7 slides on down because it's already a prime number, but the 4 will break down into 2 times 2. Now, what about this a to the third power b? Well, we know a to the third power just means a times a times a times b. So if I were to ask you to put that back in exponential form, well, the a to the third b would go back exactly as it is. So that's another reason why I don't want you writing it in an exponential form. So how would you type this one into our form? You would type the numbers in numerical order. So you would write 2 times 2 times 7, and then times a times a times a times b. So the numbers go in number form, or in number order, and the letters go in alphabetical order. So let me give you one more and have you try this one on your own. So pause the video and try this one. Oh, what did I do to you? Oh, you probably are wondering what to do with that negative. Well, you break down the 45x to the fourth yz to the second, and then when we come back to the video, I'll show you what to do with the negative. Okay, so let's find out what you did. Well, you did 45 x to the fourth y z squared. Okay, so the 45 will break down into 9 times 5, which then the 9 will break down into 3 times 3, and then the 5 slides. The x breaks down into 4 x's. The y, well, there's just one y, so I only have one y. But then the squared is actually just on the z. So it's xx, y, z, z. Okay? Now, how do I deal with that negative? Well, in order to make any number negative, all you do is put a negative 1 in the front of it. So that right there would be exactly what I'd want you to type in to the Google form. Negative 1 times 3 times 3 times 5 times x times x times x times x times y times z. And in between each one, you would put an asterisk. Okay? So that's how we prime factor monomials. So just remember, for the negative, all you do is you put a negative 1 out in front of it. All you have to do. You do not make the 3, the 5 a negative, because this part is what's prime factored. This negative 1 is not prime. It's just how we make that monomial negative. There's a reason for us doing that, so just trust me on that one. So what you're going to do for your assignment today is the very same exact thing. Okay, it says for each number or monomial, factor it completely. Write your prime factors in number and letter order. Do not write your answer in exponential form. Circle your final answer. Okay, so if you're doing it on a printed copy, then I just want you to circle your final answer. If you're doing it on the form, you're going to type it in just like that. So let's look at the 16 real quick. We'll do one of these together. So the 16 breaks into 4 times 4. So then this 4 breaks into 2 times 2. This 4 breaks into 2 times 2. So we would write out 2 times 2 times 2 times 2. And if you're doing it on paper, you would circle that final answer. Okay, so here's the first 9. Then I also want you to do a couple more. And then, yes, there is a writing activity. So until next time, this is Prime Factorization.